Evening, everybody. I'm just going to give it one more minute because there's lots of people streaming in. Hello, Cabello.
Now the possibility of
Okay, I think that. All right, Rene, let me introduce you. I think everyone. I don't think we are recording. Okay, cool. Evening, everybody. So welcome to our. We've had a few weeks now of online short courses. Last week we did some R, and this week we are doing an introduction to Python. Our presenter today is Rene Stander. I'm going to say Dr. Rene Stander. She's in limbo. She's finished her PhD, but she only graduates in September. So she's like a doctor. Okay. But if you want to call her doctor, just, feel free. So she recently completed her PhD in mathematical statistics at the University of Pretoria. And she is in the Department of Statistics at the University of Pretoria as a lecturer in a permanent position. She has valuable experience in teaching coding concepts to first and second year students, and she enriches the educational experience by bridging theoretical knowledge with practical skills. Her research focus is in spatial stats with an emphasis on measures of spatial similarity and hotspot detection as well as prediction. During her doctoral studies, she developed techniques to identify geographical areas of risk of becoming hotspots with specific application to infectious disease modeling as well as in crime and criminology. So you are in very good hands tonight. Rene will provide you an introduction to Python, and I'll be here if there's any questions. And Rene, I'll help you with the chat if there's anything. But just shout if there's something I must help you with as you're going along.
Yes. I can't see the chat, so I would appreciate if you can help.
Okay, I'll keep an eye on it for you. No problem.
Okay. Yeah.
Okay.
Okay. Thank you for the introduction and good evening, everyone. I think it's evening already. So today I'm going to give you an introduction to Python programming. So I want to just emphasize that it's an introduction. There's a lot to Python programming and you can do so many things. But my goal for today is to just put your toe into the water so that you have some place to start. And if you want to use Python in your research or your work, so that you at least know what it looks like, what the basics of the programming language, so that you can further yourself, help yourself further in that. So just briefly what we're going to do today. So we're first going to do a short introduction of Python, then some basic syntax of the programming language, then going to do a little bit data manipulation, how Python works with data visualization, and then just some basic statistical analysis, some exploratory data analysis, and I'm just going to show you what a linear regression model looks like, just to get you started with everything. I am going to hop around between Python, between the slides and some coding exercises, so I will take you through some practical examples as well. Some nice resources that I found on Python that I've also used to put together this material for this workshop is the first one is this book called Think Python. It's more on a computer science angle, but the first few chapters have very nice introductory resources on Python and how it works. It's very well written, very simple, easy to read. I definitely recommend that book if you want to have more resources as well. And then the second one is also, it's an online book, but you view it online. It's more of statistical applications in Python. Okay. So then, I'm just going to give a few minutes. I've added some coding scripts for the course on this GitHub link. If you want to follow along, please go there and just download the scripts from there so that you can open it on your own computer. I don't know if I'll be able to put it in the chat.
I'm busy typing it for you there into the chat.
Ah, thank you. And here where there's spaces, it's actually an underscore. So if you click on the link, it should take you directly to the page, and then you can just download, I think, individually, or you can download all of them as a zip file, if I'm not mistaken, all of the files there.
Hi, how do you download?
Let me just quickly.
Maybe just go to the link, Rene, and just show them where. Yeah, there we go.
Let me just hide. Let me click. So if you click on the link, this is what you will see. And then if you click on this code, there will be a download zip. So you can download it as a zip file, or you can click on the file, and then on this corner, there's a download button on the right-hand side, and then you'll be able to download it. Then you have to do it one by one. Can I continue?
Yes, thank you.
I'm just going to hide. Okay. So just the introduction to Python. So why are we learning Python? Why do we need it? So Python is actually a mature programming language. It's quite old. It's developed in the 1990s. So older than the rest of the programming languages. And so it's quite developed. It has excellent properties, especially for beginners. It has a lot of functions and functionalities. It's currently one of the most flexible programming languages. So you can do quite a lot, from basic programming, statistical applications. You can even write some applications in Python, so you can do very complex things. On the next slide, I will show you some applications that has been a part of the code is actually written in Python. But also it has a large ecosystem of libraries for statistical applications. So some apps that you might know that as part of their development in Python, it's actually quite popular ones. So Spotify, Uber, Netflix, Pinterest, Facebook, and Instagram. So some of them has smaller parts than other, written in Python, but Python did play a role in all these app developments. Okay. So installing Python. So as with R, you need the raw language as well as an IDE, so something like a shell that you can work with. With Python, the best way to do this is with the Anaconda Navigator. So if you download the Anaconda Navigator, you actually download everything that you need for Python to work on your device. And then the Python IDE that I like to use and that I'll also use in this workshop is Spider. So with Spider, you can access Spider through your Anaconda Navigator. So yeah, Anaconda can be downloaded from this link. It was also on the advertisement, so hopefully everyone has downloaded it. Okay. Then Spider looks like this. So on the left-hand side, you'll have a script editor. So this is where you can write your Python scripts and edit it. On the right-hand side, it's split into two parts. So the top part is, it's called the help pane. So you'll see different tabs here at the bottom. So there's the help, also variable explorer. So that's where you'll see all the variables in your environment. And this is also where your plots will display. Okay. And then at the bottom right, that's your console where your code will be running. Okay, you can customize this as well. You can give it a dark theme. I prefer having the white background. But if you prefer the dark background, then you can change that. Okay. Then some Python libraries mostly used in statistical applications. This is a list of them. NumPy we will use in this workshop. So that one helps with arrays. So it works with arrays, vectors, and things. SciPy is for scientific computation. So it's optimization, signal processing. And then Matplotlib is one of the data visualization packages. Pandas, that one works with data frames and data sets. We will also use that one. And then most of the data analysis tools, that's in scikit-learn. Okay. Then let's start with some of the basics of Python. Okay. So where we always start is the basic mathematical operations. Okay. So basic things that you can do. So you can do some addition, subtraction, multiplication, division, and then exponentiation. Okay. So addition is just the plus symbol, subtraction is the minus symbol, multiplication is the star, division is the /, and exponentiation is a double star, the double asterisk. Okay. This one is quite important because in other programming languages, we might use the little hat sign, but that means something else in Python. So if we go to Python, so this is my spider, we can type all of those operations in the console. So let's say what the operations on the slide. So let's say 40 plus, oh, my numlock's not on, 40 plus 2. Okay, so it's a basic operation and it will immediately give me the output, which is 42. Okay. And multiplication, 6 times 7, and it immediately gives me the answer of 42. Okay, so it's also, you can use it as a calculator if you don't have one handy. Okay. Okay. And then also you might want to save something like a calculation that you did into a variable so that you can use it later on. So these variable names, these are some rules that you can keep in mind. It can be as long as you want. Okay, there's no restriction on how long it can be. It can contain letters, numbers, and underscores, but it can't start with a number. Okay. So, and then it cannot contain one of the Python keywords. Okay, so these are some of the Python keywords, but if you use it, it will error. I'm sure. So, okay, just keep that in mind when naming variables. Okay, and unlike a programming language such as R, you can't use a full stop as part of a variable name. In Python, that has another meaning. So, but I will get to that later on. Then variable assignments use the equal sign to assign a variable. And that's the only variable assignment symbol. So let's, in the Python console, if we say A equals 7, so now it won't show me any output directly, or let's make it an operation. So 7 plus 3. Okay, so it won't give me the answer now directly if I run this. But if I want to see what is in A, which is 7 plus 3 is saved into A, which is 10, I can just run A and it will give me 10. Okay. In Python, from the script, it's better practice to use print for the variable name. And I'll also come back to that later. So we'll also output 10. Okay. Are there any questions so far before I move on?
There's nothing in the chat that I can see.
Okay.
Rene, David's got his hand up. David, you're welcome to unmute.
Hi, Rene. The library in R, you certain, well, the equivalent of packages have to be installed. Some of them are not with the base installation. Is that the same for Python, or you said something to the effect of that it has everything we need? Does that mean the library's included?
So I think with Anaconda, most of the libraries, which is translated to packages in R, is automatically installed. But if you want to install a package in Python, you type in the console, you type exclamation mark pip install. Now I can't remember if there's a I think it's like that. And then the package name. And then that should run. But I think usually in the help with the packages, there's a little instruction as well on how to install it.
So it's not necessarily already there. In some cases, it does have to be installed as with R.
Yes, but I think with Anaconda, most of the basic packages are installed already.
Okay, thanks.
Yes.
Renee, in the chat, I think maybe just that your line 3 there where you've got A equal to 7 plus 3, someone's just
Yes.
asking sort of what the A means. So maybe you can just repeat it just to make sure it's clear for everybody.
Okay, so in this line 3, maybe let's make this a little bit bigger. Okay, in this line 3, I wanted to save my operation that I did, which is the 7 plus 3. I wanted to save that into a variable so that later in my code, so that I can use that again. So, and then whenever I refer to the variable A, I'm using the value that was saved, so that I don't have to, every time that I want to use the value 10 or 7 plus 3, that I have to type it in manually, that I can just refer to the variable.
I think Renee is frozen.
Oh dear, can you hear me?
2V, while we wait for Renee to unfreeze. When you mean, or maybe it's me that's frozen. Renee, can you hear me?
Yeah, Rene.
Can see Renee.
Okay, it's me. Okay, there we go. Renee, Vituvi asked the question was actually, can we assign 1 plus 2 as a statement instead of an operation? I'm not entirely sure what they mean. I presume something like a string, but I'm not sure. Maybe you interpret it differently.
Yeah, I'm also not sure what is meant there.
But
Okay.
Rene, I think you can also go to the variable explorer to show them that the variables are there. So the A, for example.
Yeah, so in the variable explorer now, the A is there and it shows it's an int and the value is 10. So int means integer. Yes.
Pretoria, you can ask again in the chat. Okay, all clear. All right, sorted. Carry on, Renee.
Okay. Okay. Let's carry on. Let me just check the time. Okay. Okay, so on this slide, I'm just going to it's an experiment. Okay, so this top part I actually got from the Think Python book. So it says whenever you're experimenting with a new feature, you should try to make some mistakes. This kind of experiment helps you remember what you read, and it also helps you when you're programming because you get to know what the error messages mean. Okay, so I'm going to go through this to show you some of the features and what happens if we do some of these common mistakes that can happen. Okay. So let's say we print our hello world string. Okay. If we print it with both parentheses, it prints. Okay. If we leave out one of the parentheses, so if we leave out the outer one, it doesn't execute. Okay, so it shows us that code is not finished. Okay, you can just fix it by closing the parentheses and it will still run. If we if we leave out the first parentheses, you can see that it does give us an error message. In this case, it says there's an unmatched bracket. So whenever you get an error like this, you know that you close the bracket, but it isn't open. Okay. Just some of the common typos that we do make in coding. Okay, so something that Python doesn't like is leading zeros. So if you type the value, let's say 0, 1, 1, so for us, even in mathematics, that means 11. But Python doesn't like leading zeros. Okay, so that's one thing that you should be mindful of. It will give you an error saying it doesn't want it. Okay. Then let's say you type in 7 and you wanted to type 7 plus 3, but you leave out the plus and you just type the 3. So it's actually numbers with a space in between. It will also give you, it can't work with it. It's missing something. Okay. So whenever you see this error, you can go and look. You missed maybe a plus or a minus or anything. Okay.
Rene, do you mind if we ask questions as you're going along? What does the print actually mean? You had print there, A or something or the other.
Okay, so the print means, so I will actually get to that a little bit later on why Python uses print rather than just typing the variable. So if you're in the console and you run the variable, it works perfectly. Okay, but the print, but I think I'll get to that a little bit later. The explanation will make more sense when I explain it later. And then if you assign a variable, let's say we assign the number 42 to a variable called n, okay, that works. But we can't swap the operation around. So the variable should always be at the start. So if you type in something like that, so we swapped it around, doesn't work. It gives us an error. Okay, it's expecting something else. So it's always the variable first, and then whatever you assign to it on the right-hand side. Okay. And then something that I actually think can be handy maybe later is if you want to assign the same value to two variables, okay, you can type it like this. So you can have x equals y equal 1. Okay. And you can see now, even in the variable explorer, you have a variable x, which has a value 1, and a variable y, which also has a value of 1. So that can be done in one line of code, in one go. Okay. So then the first exercise that I'm going to do is just to get us comfortable with the mathematical operations. I see there's a hand.
Yeah, Rene, it's a quick one. If you replace a variable by another number, would that also reflect in your variable explorer?
Wait. Yes, it will also. So if we want to assign the x now another value, let's say 3, it will update in my variable explorer. So now x has a value of 3 instead of 1. So you can also update variables. Okay. So in this first one, it's just the volume of a sphere. So it's with this mathematical equation. So it's 4/3 times pi times the radius to the power 3. Okay. So we are going to assign the radius, a value of 5, to a variable called r. And then we're going to calculate the volume, and we're going to save this into a variable called volume. Okay. So we go to Python. So this is in the exercise 1.py script. Okay. If you want to open these scripts, the best way to do it is to open Spider and then open it from Spider. Don't double click in your file explorer. Okay, so then you go open file and you go look for the file and you open it like this. That's the best way to open these Python scripts. Okay. So because we need the operator pi, that is in the math package. Okay. So this is how we import the package. We say import math. It's the math package. Okay. So we're going to run this line of code. Okay. So I made, it's little, in Python, they call it little coding cells. Okay. So with this hashtag %%, you split your code. Okay. So you can run chunk by chunk. Okay, so you don't have to run everything all at once. Okay. So we assign the radius to a variable r. Okay, so we assign 5 to r. Okay. So I can also highlight, if I just want to run the line, I can highlight the line and I can run just that line as well. And then I can calculate the volume. So I had 4/3, which is 4 divided by 3, and I multiply with pi. So what happens here is I have my package dot my function. So I'm telling Python here in this line that I highlight that I want to use the pi function from the math package. That is where you'll use a full stop. That is the reason why you can't use a full stop in a variable name, because that's how you tell Python you need to extract this function from this package. It's, yeah, okay. And then we multiply again, and we say r to the power 3. So we have r double star 3. Okay. And if we run this line, that will give us the volume. Okay. And whenever I want to print a variable or display a variable from the script, I have to say print volume. Okay. If you don't say print, so if you just say volume, okay, it will only work if you only have one variable printed in a coding cell. Okay, so it's best just to say print volume. Okay. So this one says display the answer in the console for me. Okay, and if I run that, it gives me my answer. Okay. Any questions?
There's nothing in the chat.
Okay.
Ah, there's a question. Are the brackets required?
So not really, okay, in this case, because we're only multiplying, okay. In my coding, I tend to use brackets quite a lot. Okay, so let's take it out. It shouldn't make a difference. Let's run everything again. It gives us the same answer. So I tend to use brackets everywhere in my coding. No more questions. Can I continue?
Zinzile says, can you please repeat what happens when you just type volume, presume without the print?
Okay, so let me show you. Let's say I want to display R. I'm going to take this out, just going to comment it out, and I want to display volume. Okay, so if I run the entire coding chunk at once, okay, you see it only outputs the last thing that I say. Okay, but if I say print around both of these, oh, not that, oh. If I say print around both of the variables, it will display both of the values. So for me, it's best to just get into the habit of always putting print around something that you want displayed out of your Python script.
It doesn't
I
seem like
hope
there's
that
any
answers.
questions. Yeah. Perfect.
Okay, I will then continue. So the next thing that we'll look at is conditional statements. Okay, so it's like an if. That is what it is. Okay, so we have relational operators. So that is operators that we compare values with. So double equal for is it equal to, exclamation equal if it's not equal to, and then the usual greater than, less than or equal, and greater than and equal. Okay, with these, the bottom two, it's important that you have less than, equal, not equal, less than. So it's always the less than and then the equal. Okay. So the structure of the conditional statement is as follows. So you have the word if, then you have the condition, and then a colon. And then if you press enter, Python will automatically indent. And then you write whatever code should be executed if the condition is satisfied. Okay? And you can stop there. Okay? The moment that you don't indent anymore, that is, so you exit the indent, that is when your if statement stops. So it's unlike R where you have brackets around. Okay, so use indents. And then you can also add code for if the condition is not satisfied. That is used with else. Okay, so you see if and else is below each other. Okay, at the same indentation level. So then you have else, colon, and then the code that will be executed if the condition is not satisfied. Okay. I think it will become more clear when I do the example. Okay. So let's do this example. It's an if statement that we will write. Okay. So we'll assign a variable x equal to the value of 5. And then we'll write a Python script that will output something based on the value of x. Okay, so if x is only divisible by 3, it will print the word fizz. If it's divisible by 5, it will print buzz. if it's divisible by both of them, it will print fizz buzz. Okay. So let's write that in Python. So if we go to exercise 2, okay, let me zoom in a bit. Okay. So we assign 5 to x, the value of 5 to x. Then we want to see, is it divisible by 3 and not divisible by 5? Okay. So we have if and then the condition. So in this case, there's 2 conditions. So x, the percentage sign is the modulus sign. So let me show you what happens. So x, let's say x equals 5, x modulus 3, it gives us the remainder. So if x is divided by 3, what's the remainder? So if the remainder is 0, it is divisible by 0. Okay. So if x is divisible by 3, so the modulus x modulus 3 is equal to 0, and it is not divisible by 5. So the modulus, x modulus 5 is not 0. Okay. Then it will print this. So we have colon, and then the code that will execute when this condition is satisfied. Okay. And if I exit the indent, I'm now out of the if. Okay. And then I can do the same to check if it's divisible by 5. So we have x modulus 5 equals 0. So is the modulus of, is it divisible by 5? And it's not divisible, oh, this is the typo, not divisible by 3. So this should be a 0. Then colon, we execute this code. So if my condition is satisfied, what is the code that should be executed? Okay. And if it's divisible by both, so with this condition, we have a certain code. Okay.
Rene?
So in this case, yes.
Question of what does modulus mean? So,
Okay. So modulus is if we divide a number, so our x is 5. So if we divide the number by 3, what is the remainder? Okay, so 5 divided by 3 is 1 with the remainder of 2. Okay, so that is the answer. If we divide 5 by 5, the remainder is 0. The answer is 1. Okay, so it's the remainder. So it's usually used when you want to check if something is divisible by something, by another number. Okay. So you can also write it in one statement. Okay. So you have if, the condition, and then the code that should be executed if this condition is satisfied. And you can, in the slides, we had else over here. Okay. But if you want to have another condition, you use if. Okay. And then you have your condition, the code that should be executed if this condition is satisfied, and you can go and so on. Okay. So if means else if. If this first one is not satisfied, it will go to the next level and to the next level. Are there any other questions?
Rene, how did you open your files here in Python? You know, you've got the list of your files there, exercise 1, exercise 2, and so forth.
Yes. So I open Spider. Okay. And then I open my files from Spider. So I click on this open file, and then I go search for it in my file explorer.
Okay, thank you.
Yes.
Excuse me, Rene.
Okay.
Rene.
Okay. So the next thing that we can do is loops. Okay. So for loop is the first type of loop that we will look at. So that is code. The code inside the loop will execute a specified number of times. Okay. So we have for. That is the keyword to start the for loop. We have an index, and then we say in, and then the possible values of the index. And again, we use the colon, and then indented, the indent is important, the code that will execute at each iteration of the loop. Okay. The moment the indent stops, so the moment you exit the indent, your loop is finished. Okay. So in this case, we had I in a range from 1 to 5. Okay. What happens here is if we print this, if we run this for loop, we only go, the I only iterates from 1 up to 4. Okay. It means what it actually means in this possible values is that the last value is excluded. Okay, so I will say it a few more times. That is something in Python. The first value in the range is included and the last one is excluded. Okay, so this list is actually 1, 2, 3, 4. Okay. But I will say that again later. So that's something we should be mindful of. Okay. And then the other loop that we can look at is the while loop. So in this case, the code inside the loop will execute while a specific condition is met. Okay. So in this case, we have while, and then the condition that should be met for the loop to continue. And then again, the colon, and indented under that, the code that executes at each iteration. Okay. And there it's important to update, so that the condition can be met at some point. Okay. Are there any questions at this point? Because I think for the interest of time, I'm going to skip over exercise 3, which is just the loop.
There's a question that says, I don't know if I missed it. How do you set your current working directory? Inspire.
Oh, I'm going to do that now. I'm going
Okay,
to, in one of the next exercises, I'll do that.
Perfect.
I have a question.
Yes.
So for the loop, that I that you was present in the loop, is it built in, or did you have to define it somewhere? Or it knows
That is some
for I.
Yeah, so that is the index. So you can use whatever you want there. You can use a J, a K, a word. So that's just the index in the loop.
Okay. Thanks.
Yes. I see there's a hand.
Hi. The indentation that you refer to quite a bit, is there some rule about how many spaces it should be indented by or anything of that sort? Or is it just as long as it's indented by one character at least, or one space at least?
So it's one tab. So it's only one. Yeah. Python is quite fussy about the indentations. So it's one, you press tab on your keyboard. So it's only one.
Thanks.
But if you type this 4i, this part, the stop part, and you add your colon and you press enter, the indentation will be automatic in Spider. Okay. So the next thing that you might use is a function. So this is a block of code that performs a specific task. And in coding, it's good to write a function for tasks that repeat quite a lot in your script. It makes it a little bit neater, but it's just to make life easier if you want to write functions. So there's obviously a whole lot of built-in functions, but there might be something that you want to use or repeat quite a lot that there's no built-in function. So then you have the ability to write it yourself. Okay. So the way you define a function in Python is with this def, okay? And then you have a space, and this first part is your function name, okay? Your function name, you can also see Spider makes it bold letters. Okay. And then you start parentheses, and inside the parentheses, you specify the parameters. Okay, so that's the parameters that you will pass to your function that will also be used. So in this case, you can see the parameters for this function is x. So I know if I pass a value to the function when I use it, that is x, and it's referred to x everywhere else inside my function. Okay. So then I again have the colon, and if I press enter, it will be indented automatically. Okay, so again, indents. In this case, this example is a function that will calculate the absolute value. Okay, so I give it x, and then I look, is it a possible value, a positive value or a negative value? If it's a positive value, if x is greater than 0, it will just return x. Okay. So this return value, whatever is in return, is going to be the output of the function. Okay. And then again, the moment that I stop the indentation, my function is complete. Okay. So when I use it, I call the function with its name, and in the parentheses, I can pass a parameter. So, and you can also save that to a value A or B or whatever. You can save it to a variable. Okay. So I have in this line, just below where I define my function, I'm not sure if you can see my cursor. I have A equal my function value, and then in parentheses -5. Okay, so in this case, I'm calling the function that I just wrote with a parameter 5, and I'm saving whatever output it gives me into a variable A. And then the same at the bottom. So I have just below that. So I call the function absolute value 10. I give it the value 10, the parameter 10, and I save the output to a variable b. I hope that makes sense. I'm going to this fourth exercise, because we have already done the inner part of the function. I'm just going to go through this code to show you how the function works. Okay, so exercise 4. Okay. Okay, I'm going to get to the packages a little bit later. It's not needed for the part that I want to show now. So if we focus on this part that's highlighted in yellow, okay, so I'm defining a function. I'm calling it this fizzbuzz. Okay. In the parentheses, I have the variable x. Okay, so wherever I'm referring to x, I'm using the value that's being passed to the function. Okay. And then I have my code that we wrote in exercise 2, okay, to determine which word should be displayed. So if I run this, oh dear, what happens? Oh, okay. If I run this function and I want to call this function, let's do it in the console. I want to pass it the value 5. Then this code inside the function is going to run with x equal to 5. And 5 is divisible by 5, so it will output this buzz value. Okay, that is what it outputs. I can also save this as I did previously. Let's call it, very creative name, A. Let's say 6, okay? So I'm saving the output of this function to a variable called A. So if I just print A now, it will give me the output of this function, but it's now just saved into a variable. Any questions up to here?
There aren't any in the chat, unless they're busy typing. No, you can carry on, Rene.
Okay. So the next thing that we are going to look at is lists. Okay. These you might use later on again, maybe, or it's usually useful to know how to work with lists and vectors in a programming language. Okay. So a list is a sequence of values. Okay. The elements can be of any type. So it can be numbers, it can be characters, and you can even have lists inside a list. Okay. And then the elements within the list does not have to be of the same type. So you can have numbers and characters and even lists inside the same list. Okay. So you're not restricted to only numbers or only characters. Okay. When you have a list inside another list, it's called nested. Okay. But I'm not going to go into nested lists now. It's just so that you are aware of the terminology. Then the example that I'm going to do on the lists, I'm rather going to do that in Python than doing that on the slides. Okay. Let me just make this a little bit bigger. So if we consider this list A, okay, we define the list with square brackets and separating the elements inside the list with a comma. Okay. So we have now a list with 2, 6, 8, and 3 in. If we want to extract an element, let's say the second element, we can do that with the square brackets. Okay. And the indexing in Python starts with 0. So if I say A square brackets 1, that's going to extract the second value, which is 6. So if I extract the value in index 1, it's 6, because the indexing starts at 0. Okay. If I want to extract, let's say, the first 3 elements, I again do the square brackets, and then I can say I want from 0 index, so that's the first value, up to, but we should remember the second argument is always excluding. Okay, so I say 0 to 3, and that will actually give me the values in index 0, 1, and 2. That's something to remember and to get used to in Python, because it's different than others programming languages. Okay. So if I run this, it gives me the first 3 values. Another way that you can also do it here is because you are extracting from the first element, you can also say A and just say colon 3. That will extract also the first 3. Okay. Then you can also update lists. Okay, so if you want to change the third element, so the one in index with index 2, you can have the A with the square brackets and the index, and then equal to the updated value. Okay. So if we print that, so remember my A was 2683, and I want to update the third element. So the 8 will now change. Let's see if that happens. It will change to a 5. Okay. So you can see I updated the third element. So if I want to change more than one element, okay, so if I want to change the first element to 2 and the second element to 8, I can do it like this. As I would extract multiple values, I can also update multiple values. So I have A, the square brackets, the indices, and then I update it with another list. So I update it with 2, 8. Okay, so the 2 will go into the first value and 8 will go into the second one. Okay. So that stays the same. Okay. So it's 2, 8, 5, and 3. So we can extract and we can update. Then with lists, in Python, that's quite easy. We can also concatenate lists. So let's say we have two lists. So we change A back to what it was before. And we have another list called B. So we have these two lists. You can now see it in the variable explorer. If we concatenate the list, so we basically just stick them together, we can use the plus operator. Okay. So in this line, we concatenate the lists and we save it into a variable called C. So if we print that, you can see we have, there's our elements that's in A, and there's our element that's in B. Okay. And you can also create a new list where the values of B is repeated multiple times. Okay, so we can do that with the multiply symbol. So if we do this, and so we create B 3 times, repeat it 3 times, and save it into a variable D. This is the output. So we have, there's B, there's another B, and there's another one. So it's repeated. That's how you do this in Python when working with lists. Okay. Are there any questions before we move on?
Interesting question. Ben asked, what is the code to extract the second and the fourth element only?
Okay, so that is an interesting question. It's not as simple to do it with just one operator. I can never remember it from the top of my head. But it's can't remember it. But it is a little line. Let me. This is the cool thing about Python. You can Google it. Extract. I hope I get the same. I will have to look for it again.
I would also think, so I think if it's just 2, you could do it one by one. But if it's a whole bunch, you'd actually maybe put those indices in their own list and then loop through that and extract them like that. For example.
Yeah, it is a loop type of operator. Yeah, I can't remember from the top of my head now. But yeah, if it's 2, it's easy because then you can just concatenate them. Yeah. But if you play around
what you want to do with it, I think you've got to think, yeah.
Yes, yes. Okay. I'm going to go on. Okay, so the next part is the data manipulation, then the visualization, and then some of the statistical applications. So in the data manipulation, I'm going to do it solely in Python, in Spider. We are going to import data sets, extract variables, remove some variables, subsetting the data set, and also removing some of the observations. Okay. So the data set that we are going to use for the next few examples is it's actually a quite, I think, innovative thing from some university in the USA. So it's actually like a game that they let their students play. You can also go to this website and go and play the game, but you can also download the data. So that's where this data comes from. And then for this example, we are going to use the data underscore manipulation file. And all the instructions are in there. Okay. So I'm going to go over to that file. Okay. Just going to close some of these. Okay. Okay. So we start by importing the necessary packages. So as I have said in the beginning, Pandas is the package for you working with data sets in Python. And as I have said in exercise 1, when you want to use a function from a package, you have to say the package name dot the function. So there's like conventions used. So we import the package as, then we give it an alias. Okay, so this is a well-known alias for pandas is PD. So we import pandas as PD. So that's the first package. Then the second package, we say import OS. Okay. And in this package, we are going to set our working directory. Okay. So to set our working directory, we use this function. So we have os.chdr. So this one says change directory. And then in the parentheses, we give it the file path of the directory. It is in inverted commas. And you will see that I have backslashes in my file path. Because I have backslashes, I have to put in front of my inverted commas the letter R to tell Python that it shouldn't ignore the backslashes. You can go and change it to forward slashes. It's easier to just use the R. Okay. So if I run this code, it runs the entire cell. Okay, my working directory has changed. Then I'm importing the data using the read underscore CSV function from the pandas package. Okay. And my data is inside my working directory. So I don't have to specify the path again. And I'm saving my data as racing. So now you can see in the variable explorer, there is a variable racing. It is a data frame, and it does give me the size. So next, you can obtain the variable names using the list, okay, the list function. So if I run that, it will give me all the variable names in the data set. To obtain the dimensions of the data set, you can use the function shape. So in Python, what you do is you type your data set name, your variable, dot whatever function. Okay, so in this case, it's shape. So if I type here racing.shape, it will give me the number of rows and the number of columns. If I only want the number of observations, I extract the value in index 0. So if I run this, it will give me the number of rows in my data set. To obtain the number of columns, I use the index 1. So it will give me the number of columns. Okay. I can also obtain the data types of each column with D types. So it's racing.d types. And that will give me the data types. Okay, to extract a column from my data set, I use the square brackets and in inverted commas, the name of the data set. Okay, so in this case, I'm saving it to a variable called tracks. So you can see in tracks, this is my variable. Okay, so I have extracted the tracks column into another variable. To show the unique values in a column, you can extract the column and say dot unique. And here you have to say open bracket, close bracket. Okay. To say that this function is applied to this variable. So if you run this, you look what is in track types, you can see that it does give you the 3 track types that's used in the game. Complex track, oval track, and straight track. So if we subset the data, okay, let me just drag this a little bit bigger. So if we subset the data to only contain the races on the oval track, this is what we do. So we use the dataset name dot LOC, which stands for location, okay? And then we have the square brackets. So we have the condition, which is that track should be equal to oval track, okay? And then comma, and after the comma, we have a colon saying we want all the columns. So we want the rows that has oval track, but we want, where track is oval track, but we want all the columns. Okay. So that's one way to subset. Okay. If we want to subset to, so only the races on the straight track and the oval track. So there's 2 options for track. Okay. We can create a list of the possibilities. Okay. And then we again have the racing.loc, and we have the column dot is in a function. And then in the parentheses, we have the list of possible values. So it should be, this track should be either straight track or oval track, then it will be included in the subset. Okay. And again, we have all columns. If we want to subset based on 2 columns, so in this case, the track is oval track, and the car had a base engine. Okay. Again, the racing.loc. Okay. And then we have the track should be oval track, and the engine should be base. So we can add the 2 conditions in. What's important here is each condition should be in parentheses, And this should be the ampersand sign. And then again, the other condition should be in parentheses. Okay. And again, we have the comma, and we take all the columns. So we put the colon after the comma. Okay. So if we remove a column, we specify the data set, and then we say drop. So dot drop. Okay. Then we specify the column which we want to remove from our data set, and x is equal 1. So this says that it is a column that needs to be dropped, the axis. So if I run this code, I can see that the racing 2 has one less column than racing. So it dropped an entire column. Okay. And if we want to remove some of the observations, let's say we want to remove the last 10 observations, we will subset the data set, and we will say we want all of the values, all of the rows until the 10th last value, the 10th last observation. Okay. So that is, let me run that, and you'll see that the number of observations reduced. Okay. And then this last part, I think when you go over this code in your own time, you can explore a little bit what happens here. But what I want to show here is that you can add a new variable, okay, by assigning a value to the new column like this. Okay, so this will create a new column based on the value. And then what happens on this right-hand side is we are actually applying a function onto a certain variable. So we're applying this function that we wrote here at the top to a certain variable. So we are creating a new variable based on the value from an existing variable in the data frame. Okay. Are there any questions on the data manipulation before we go to the visualization?
I don't think, doesn't look like there are any. Sharp, I got a sharp, so seems good.
Okay. Let me just go to the visualization. Okay. So the two main packages in Python for the data visualization is matplotlib and Seaborn. Okay, so matplotlib I did mention at the beginning. For me personally, Seaborn is a little bit easier, and they actually work together. So you can use matplotlib functions in Seaborn. Okay. So I'm going to show you how to make bar plots, histograms, scatter plots, and box plots. Okay. So so bar plots for categorical data, and histograms, scatter plots, and box plots for numerical data. Okay. Obviously, with the visualization and the plots, there's actually a lot that you can do. I'm going to give you brief what you can do, just to make you eager to explore more. But as I said before, with Python, there's many help sites on the internet. So please explore more and look what you can actually do with the visualizations. I'm only going to show you some of the functionalities. Okay. So, okay. Okay, so again, in this example, we are importing pandas and we're importing OS because we want to set our working directory. Okay, I am importing Seaborn, and the conventional alias for Seaborn is SNS. Okay, it's just easier if we want to call a function. And then I'm also going to import matplotlib because I want to use some of the functionalities from matplotlib. So I'm importing the pyplot part of matplotlib as PLT. Okay. And I'm just going to run this again. So I'm working on the racing data again, the same as we did in the manipulation part. Okay. So if we want to draw a histogram of the finish time variable. So in Seaborn, we use the histplot function. The first argument, we give the data, and in the second argument, we give it the variable. Okay. So if I run this, it's not necessary to run the plt.show, but if you run this and you go to the plots tab, it will give you the histogram. Okay. I added the plt.show because otherwise it's just going to keep on adding to the previous plot. So if you add the plt.show, it says, okay, this is the plot. And then the next plot line of code is executed, is then seen as a new plot. Okay. So let me just do that. Okay. So now you can see it did make a histogram, very basic. It used the x-axis as, or the x-axis title as the name of the variable, and it had the default count. We can change that. So the easiest way to do that is to actually assign this function, this histplot function, to a variable. And then in the new line, we have that variable dot set, and then we can specify the labels. So we can give it an X label, we can change the Y label, and we can even give it a main title. Okay. So that's setting the labels. There's more customization that we can do. We can change the color of the bars. This is done in the histplot function. We can change the edge colors of the bars, and we can also change the number of bins. Okay. If you search for this function in Google, you will see much more functionalities and arguments as well. So let me show you what happens if I run this line of code. This is what happens. So I changed the x-axis label, I changed the y label, I gave it other colors, and there's also now a main title. Okay. So the next type of plot is the scatter plot. So if we add finish time on the x-axis and the top speed reached on the y-axis, we can use the function scatterplot. Okay, and we specify finish time is on the x-axis, y is on top speed reach is on the y-axis, and I just decided I'm going to make purple observations. Okay, and I from the get-go changed my x labels and my y labels. Okay. So if I run this, that is my scatter plot. Okay. I can also color the dots according to what engine was used. Okay, and so this part of the code is exactly the same until there. And to specify that engine, it should be colored according to engine, I use the argument U, HUE. Okay. And I can also specify which colors should be used for which engine, which is quite easy. You just add the labels with the colors that should be used. Okay, so these are the hex codes for the colors. So you can also add the hex colors. You can, of the codes, you can type in the name of the color, or you can actually go more fine and define the color with the code. Okay. Okay. So if we run this part, okay, you can see that the dots are now colored, and we actually have a little legend. Okay. So we can also move this legend. So this is what happens with the move legend. So we specify where we want it. And in this case, we specified 1, 1. And that will actually put it on the outside of the plot. Okay. Yeah, so there's different positions for the legend, but there's help on Google. So you can just wherever you need it for your visualization to make it the best for you. Okay. So there's my legend on that. In this case, the plot is too busy on the inside, so the legend is better on the outside. Okay. My suggestion will be, if you want to make the plots in Python, is to start out because you have the coding scripts, but to start out with this code as a template, just to get started, and then you can just add on and change as you see fit. Okay. Then to draw a box plot, we use the box plot function. Okay. And on the x-axis, we have our variable. Okay. So just the box plot function. And if I want to make it a vertical box plot, I can just change my x to a y. And then it will make it vertical box plots. Okay. So if I want to draw a box plot for different categories, so having a side-by-side box plot, I can specify the numerical variable as well as the categorical variable. Okay. And if I run this, it will make a side-by-side box plot. So for the finish time for each track in this case. So for each track the race was completed on. Okay. So you can specify the colors for each box plot as you did before. So you use this palette argument. Okay. And then something you can manually add is the tick labels. Okay, so to make it pretty, you just use the set X tick labels and you give it the list of the labels that you want to give for the X axis. Okay. So then to draw a bar plot, okay, to show the number of races completed on each track. Okay. So you cannot draw the bar plot directly. You first have to create a contingency table. So that is done with this line of code. So we have the variable, the track variable, and dot value underscore counts. Okay, so this is going to create a contingency table. So if I have racing underscore track, you see there's the different tracks and there's the number of races completed on that track. Okay. If I draw the bar plot now, oh, this is not the correct one. I will update the GitHub. Okay. So this is then bar plot. And on the x-axis, I want the labels, so complex track, oval track, and straight track. So I have racing track dot index. So it will give this values. And then on the y, I want the actual values. So I have my racing track dot values. Okay. So if I show this bar plot, that is what it looks like. So it does need the contingency table. You can't give it just your variable. Okay. Are there any questions on the data visualization?
There don't seem to be any questions, Rene.
Okay, thank you. Okay. So as I have said, that with the visualization, the best way to do it is by exploring it when you are actually wanting to make the plot. Okay. Then the last part is the basic statistical analysis. So we're first going to look at some exploratory data analysis. So that is getting the mean, 5 number summaries, how to calculate a standard deviation, interquartile range, and the categorical data. I have just shown you how to do a frequency table. So I'm not going to do this in this part. Okay, so I'm going to focus on getting mean, 5 number summaries, standard deviation, and interquartile range. Okay. So we are again using the racer game. So we already have the data. Okay. So to obtain a quick summary of all of the finish time variable, okay, so this will give you the 5 number summary. We have racing finish time, so we specify the variable and then dot describe. Okay. So if we run this, you can see in summary, we have a summary. So we have the count, how many observations there are. It gives us the mean and the standard deviation, and it gives us then the 5 number summary as well. So the minimum, the first quartile, second quartile, and so forth. Okay. Then if we only want the mean, Okay, so there's two ways to obtain this. Is to take your variable and then apply the function mean to it. So say dot mean, open bracket, close bracket. Or you can extract it from the summary. Okay, so by saying summary and then extracting mean with the square brackets. So, this is where I wanted to show about the print, but I have said it before, but let me show again. So if I run this entire coding shell, it only gives me one of the values. But if I say print after around the statements, it gives me both values. Okay, and you can see it does give the same value. So there's multiple ways of doing the same thing. Okay. To obtain the minimum value, hey, again, you can apply the function min to min to the variable. Okay. Or you can extract it from the summary. So with this print function, it's another functionality that I want to show you. You can actually add text to your output. So in this case, I want to say minimum, that the minimum is this certain value. So if I run this, you can see it outputs minimum and then the value. Nice. This will be handy when you print multiple values, so that you can actually label what value is printed. Okay. And we can also calculate the maximum. Again, with the max function, you can also extract it from the summary. Standard deviation, the same or similar. Median, also similar. And then with the interquartile range, there's a calculation that you can do, because the interquartile range is just the third quartile minus the second quartile. So you can just do that calculation directly from the summary function. Okay. So if I print this, you can see that's the value. Okay. Are there any questions before I get to the last part?
I don't see any questions.
Okay. So, okay, so the last example, I'm just going to do a linear regression. I'm sure everyone is familiar with that. So we just have a dependent variable, and it's a simple linear regression. So we just have one independent variable. And with linear regression, we assume a linear relationship. Okay. For this example, we are going to use a Kaggle data set, okay, with salaries versus years of experience. So I'm going to see if there's a relationship between the years of experience and the salary in this data set. Okay. So we are going to look at this Python script linear regression. So this should give you an idea of how Python works with models and, yeah, regression type of applications. Okay. So in this script, we are using pandas again. We are going to do some visualization with Seaborn and Matplotlib. Okay. And we're also going to use NumPy, which is the one for arrays. So that NumPy's alias is NP. Okay. And then we also need to import the linear regression. So what is a nice feature also about Python is you can import only one function from a package. Okay, so this is from the scikit-learn package, from the linear model part of it, and we're importing just the linear regression function. And we're also going to show or use a metric. So from the metrics, we're just going to import the function R2score. Okay. So we are setting our working directory and we are importing the salary data sets. Okay. Okay. So we are going to first split the data set into the dependent and independent variables. So we're going to set our X and our Y. Okay. So we're going to extract salary and use that or save that to a variable Y. So it's just easier to use later on. And we are going to extract the year's experience into a variable called X. Okay. What you notice here is that we do something with the variable year's experience before we save it into the variable X. Okay. So what we are doing is I want to quickly show you the shape of the year's experience. Okay, you see there's 30 observations, but it doesn't have, according to the shape, it doesn't have columns. Okay, so it's just a vector. We want to make it a column vector so that it has a 1. It shows it as the dimensions 30 rows, 1 column. And we do that with this function. So we make it a NumPy array, which is np.array, and then we're going to reshape it. Okay. -1 means it figures out how many rows there should be. So we don't enter the number of rows, and it's going to give us 1 column. Okay. So let me run this, and then I'm going to show you what is the dimensions of that X variable. So now the dimensions is 31. So there's 30 rows, 1 column. So it's different than what we had before. That's important to do that. Otherwise, the regression model is not going to work. Okay. So when we fit the linear regression model, we start by saying, creating an object, a linear regression object, with the linear regression function. We save this into a variable lin_reg. Okay, that's what we call this object of ours. Okay. And in this model, we are going to specify that it has to fit an intercept. Okay. Otherwise, it's not going to fit an intercept. Okay. So this line of code creates an empty object for linear regression. Okay. Then we are going to apply the regression model. So we're going to fit the model. So we do that by specifying our object that we created dot fit. So we are applying this method. Okay. and we're going to say x, y. So we give it our independent and our dependent variable. Okay. So we run this. So now we fit our regression model. So you can, if you type in your console here, linreg dot, and you press the tab button on your computer, on your keyboard, okay, it actually gives you whatever is inside that object now, okay. Okay, so we can extract the coefficients, so the intercept parameter and my slope parameter, from my linear regression object. Okay. So the intercept parameter is saved as intercept underscore. If you type in, as I said here, lin underscore reg dot tab, you can actually go and select which parameter you want to be extracted. Okay, so you can see what it is named. Okay, so the intercept parameter is named intercept, and the slope parameter is coefficient, COEF underscore. Okay. So I just want to show you what is saved here. I'm just running it line by line now, as I want to say something about the print function. So you can see we only had one independent variable, only one predictor, so there's only one parameter in there. Okay. So if we want to print the variable, okay, and we want to add a little sentence. Let's say the intercept parameter for the fitted linear regression line is this parameter. We can add this variable to my print statement inside the string. Okay, you do this by adding an F before the inverted commas, before you start the inverted commas, and then wherever you want the variable displayed, you add it there in curly brackets. Okay, so I also, as additional, just to make it neater, rounded it to 2 decimal places. So I can print these 2 statements, and you can actually see it is part of the sentence. So a neat way to display your output. If you want to obtain the y hat values, you use the predict functionality. So it's your linear regression object dot predict, and you add you pass your x variable as an argument, and that is going to give you your y hat values. So if we want to calculate the R squared value, that is what we've imported the R2 score function for. You use the R2 score function, and you give it the actual values as well as the predicted values to calculate an R squared value. Okay. And again, I'm going to display it as part of a sentence in my print statement. So I have the value of R squared is the value of the variable. And I print that, and there is actually then my value of R squared. The R squared value is also inside this lin reg object, my linear regression object. But there's always different ways to do it. In Python, there's multiple ways to do the same thing. Okay. And then the last thing of the linear regression is to create a scatter plot of the X and the Y and to overlay the regression line. Okay. So let's do it step by step. So I have my scatter plot. It's under plots. So there it is. So I have my X and my Y, my year's experience and my salary. And if I want to display the regression line, I can use the plt.plot. So that's then actually from matplotlib. And I plot the X values against the Y hat values. Okay, I specify the color. Just put that on a new line. Okay, I'm going to get to that now. I'm also changing my X label and I'm saying that I want a legend. Okay, I'll explain the legend now. So then I actually have my regression line on top of my scatter plot. Okay. So you can also add layers then on. And I can give a label to this line. So I can either say fitted line, what I want. So you do that with this label argument inside this plt.plots function. In this case, you'll see that I actually added the equation for the regression line to the label. Okay. So what you do with that, or how you do that, is you, in label, in the inverted commas, okay, you can add LaTeX code as well. So with the dollar signs, that's saying that you'll have something in math mode, y equal, and the same as how I printed the value of the variable in my print statement. I again use the curly brackets to add the actual value in this string. So I have my intercept parameter plus my slope parameter and then the X value. Okay. And just because there's quite a lot of decimal places, I just rounded the values so that it looks neat. Okay. And then you add, before the inverted commas, you add RF so that it knows that it's working with the math notation, and also it should go and fetch the variables to display as text in my legend. Okay. Are there any questions on this part?
Anyone want to add to? There's been a few questions in the chat, but they were simple ones, so I sort of answered them for you. But maybe if someone wants some, they weren't Python questions, you see, so I could answer them. Anybody, any questions? Anything more you want to ask? David?
Yeah, thanks. So does that F, which you put into print, is it the F to tell you what the format must be, or is it to tell you that the variable that you're going to be putting a variable name together with a string?
Okay, so this F tells, I think it actually stands for format string. So it's the type of string. So this one, as you have said, the second option, it does give, it tells the string to expect a variable.
Okay, so it's
That
got
you will
nothing,
be inputting a variable that it has to fetch from your variable explorer.
okay, but it's got nothing to do with the fact that you formatted the output, the variable. The F doesn't stand for format.
I actually think it does stand for format, but it is just so that you can add a variable to the string.
Okay, so you don't have to do it you don't have to stipulate the format, or you do.
I'm not sure that I understand 100% what you're saying. Doesn't mean that you have to round. That's not why you put the F there.
No, I'm saying the int comma 2, do you have to have that format, output format stipulated, or can you do without it?
So if you want to add like the variable value inside the string, like I did here, you have to put the F.
Yeah, no, sorry, I'm saying, do you have to stipulate what the format of that's going to be?
Oh,
Okay.
no, you don't. It does that automatically.
Okay, thanks.
I don't see any other questions.
If there's no other questions, I just want to say thank you. And I know it was a mouthful, but if you have any additional questions, you're welcome to communicate them to me. Yeah, I know, but I hope that gave you just a starting point on a Python journey. So yes, if you have any additional questions, you're welcome to get into contact with me. And if you still have any questions that I can answer now, I will be here.
Okay, there's that question here. Any specific reason why you use Anaconda? Could Jupyter Notebook be useful as well?
It's you can use Jupyter Notebook. I know that is also used. I learned Python through Anaconda and Spider, so I haven't tried anything else before. But many people work with Jupyter Notebook.
Whatever works for you. If your code works, your code works. That's always my.
Yeah. If it runs, that's fine.
Done it. It's fine. Okay, you've got Renee's email there on her Shed's page there. I also put my email. It's now a bit further up because everyone's expressing their gratitude for you, Renee, in the chat. But you're very welcome to email us if you have questions. And I have said in the chat, but in case you missed it, the NITheCS does put the recordings of their seminars and webinars onto their YouTube channel. So if you want to go and listen to Renee again, you can get it there. I don't know, it's not going to be there like immediately, but it will be there at some point. And then don't miss out on Thursday. We've got an introduction to QGIS and spatial analysis. If you also want to learn a little bit about that. So QGIS is an open source GIS software. So if you're in any space in that, then that's for you. And next week, Thursday, on the 13th, we'll also have an introduction to GitHub. So hopefully by the end of all of our workshops, you'll have a good understanding of all the basics and you'll be able to become experts. So thank you for everybody for sitting through us. It's you can pat yourself on the back. It's hard at the end of the day, 5 to 7 p.m. to sit through a workshop. Renee had to talk for 2 hours, so good, well done to her as well. So no, we don't share the recording. It will be available on YouTube officially there, so you can get it over there. Okay, right. Thank you, Renee. Thank you, everybody. Have a lovely evening.
Thank you.
And hopefully see you on Thursday.